So we're going to go through the solutions for progress check 12. You should check your own work and look at ways of improving your solution, your working if you did not gain full marks. So this first question, standard integration question. You've got limits on it as well, so it's a definite integral that you're working out. We don't need to rearrange anything here, it's in a form that's ready to integrate, so we can actually go straight to just starting the integral. And a rule for integration, remember that if you are integrating x to the power n, then you are going to be adding 1 to that power and then dividing by the new power. And if it's an integration without limits, then you would also have your plus c on the end there, the constant of integration. However, here we won't have that because we have limits. So integrating, that means here I'm going to be doing adding 1 to the power. So adding 1 to the power means it's going up and it's going to become minus 1. So minus 2 plus 1 is minus 1. I also then need to divide by that minus 1. So I've already got a dividing number on the bottom here, the 4. So that dividing by minus 1 is going to multiply the 4 that's already there. I'm going to put square brackets around this, and I've got 3 and 2 going on there. Now, obviously this minus 1 here multiplies the 4 and makes that overall, that becomes minus a quarter x to the minus 1 and your limits of 3 over 2. However, at this point here, you should really be interpreting the negative power before you do the subbing in. So I would also expect to see that written x to minus 1, take it back down to the bottom line, it becomes x to the power of positive 1. Now I've interpreted my negative power and I'm now ready to sub in. So when I sub in, I'm doing upper limit, which in this case is 4, minus the lower limit. Now you've got like a double negative going on here, so it's minus the expression with the 2 subbed in. So that means I end up with minus 12, a double negative, minus minus means it's actually plus 1/8. So in order to add those two equations together, those two fractions together, they need to be changed into the lowest common multiple. Lowest common multiple of 12 and 8 is 24. So in the first instance, that is minus 2 over 24, and this one is plus 3 over 24, and adding those two things together, you end up with 1 over 24. So in order to gain your marks, what you get them for is for your correct integration. And when you sub in the limits to do upper limit minus the lower limit, you're subbing in to this sort of format and you're not writing down 3 to the power minus 1 or anything like that. So you should have interpreted the correct the power notation, and then of course 1 for the final answer. For number 2, it's clearly a polynomial function, and they're actually telling you the format of the equation. And notice that there's a square on one of the brackets, and remember that this bit here, your bracketed term, that's to do with your roots. So because you can see that you've got a root right at x equals minus 1, right, that would produce a bracket where you would have x plus 1, right, would be a factor. And because you've also got a root at x equals 2, that would give you a factor of x minus 2. However, this one here, the x equals 2, is also a turning point. Right, so since x equals 2 is a turning point, then it means that x equals 2 is an equal root. Then x equals 2 is an equal root, and the equal root means that's the one where you get x minus 2 all squared. So that should help you get started on this question just from interpreting the graph. So our f of x, we've got f of x equals k times x minus a, and you've got x minus b all squared. Right, that's the routine on it. So clearly here, if we want our single bracket to be x plus 1, right, so we want this to be x plus 1, then we want that a to be replaced with minus 1. So the question is asking you to write down or find the values for a, b and k. So clearly the a will be equal to minus 1, right, not just 1. Now this matches the x minus 2 squared, right, so that tells you that the b value will be in fact equal to just 2, not minus 2. So because the minus sign's already there. And then in order to work out the last value, the k, you then need to make use of the y-intercept, the point that you have got. So you've earned a mark so far if you've got these two things correct, but then to get your, use the y-intercept to work out your value, right, to find k. So our y-intercept was the point 0, 8, correct, so 0 minus 8, right, 0 minus 8. So we are subbing into f of x, or y equals k times x minus, x plus 1 rather, and x minus 2, because we've worked out what a and b are. And we're then going to have minus 8 is equal to k times 0 plus 1, 0 minus 2. And notice at the moment that's not correct. And this is what quite a number of you had. What you forgot about was the squared on the bracket. And it's very, very important that you don't miss that out. So we have minus 8 equals k times 1. Minus 2 squared is going to give you positive 4. So we get 4k equals minus 8. And we end up with a value of k equals minus 2. And that's our third, that's the third math. But you need to show the working for that one. So this question here, number 3, right, this one clearly you've got a diagram, a coordinate diagram there, but it's also on about angles, and then it's trying to get you to find the exact value of sine p minus q. Now you should recognise that type of expression and be saying to yourself, that must be one of what we call the addition formulae type question, and you would look at your formula sheet, which you can see a bit of the formula list here at the side. So clearly we're going to be using this one, and remember the way they are written in the formula list, it does combine the two formulas in one. So if we are doing sine a minus b, so the minus signs at the bottom of that, that means when we're writing out the expression we would also have a minus sign because they match. So quite important to do that. So what information are we given in here? So we are given two right angled triangles, we've got coordinates of points, and I'm going to say you should have drawn out the triangles separately. The coordinates are just there to help you identify the lengths of the lines. So clearly from the origin along and up you've got 4 units there and 3 units there, and a Pythagoras calculation, whether you put little x on there or whether you just remember that this is a 3, 4, 5 triangle, but you do a Pythagoras calculation if you need to, or you just remember, oh, I've got 3 and 4, the third side will be 5 without having to work it out. Right, this one you've got 6. Now some of you put -8 on here. Remember, this is a length of a side. So a length of a side in a triangle can't really be negative. So the -8 is to position it. Position this point relative to the origin. It's 6 along and down -8, but it doesn't mean that distance length. So if you need to, you would do the little Pythagoras. If you've used x in the first triangle, use y there. So you'd have y squared equals, it's the hypotenuse you're trying to work out. So it'd be 6 squared add 8 squared, that's 100. Therefore y is the square root of 100. So y would be equal to 10. So that side of your triangle you now know is equal to 10. And that allows you to write down your expressions. So you were trying to work out the sine of p minus q. So first thing you should have done, write out the expanded form. So sine p cos q minus cos p sine q. And then from that, you're using each of your triangles in turn to work out your sine, cos and tan. So your 3, 4, 5 and your 6, 8, 10 triangle to do that. That would allow you to fill in your sine of p would be 3/5, your cos of q would be 6/10, and your cos of p would be 4/5, and the sine of q would be 8/10. And if we multiply these two things together, you might have simplified those. If you haven't, it doesn't matter. This would be the unsimplified version, but you could have written the 6/10 as 3/5 and the 8/10 as 4/5. So anyway, multiplying those together, you get 18 out of 50, and we get minus 32 out of 50. So we end up with our final answer minus 40, not final answer, our unsimplified answer of minus 14 over 50, and then you could simplify if you need to, or if you're still needing to, and you would have got minus 7 out of 25. You might have simplified further up that fraction, but as long as you get down to the minus 7 over 25. Now the way you get marks here, one for writing out this expanded form, and the second mark is really for having worked out the third side of the triangle and then subbed in. That gets you your values, and then this one here would be the final answer, would be your third mark. So last question, this is clearly a recurrence relation question. It's not a routine one, however it is quite similar, I'm going to say, to and it'd be worth you having a look at this afterwards if you had difficulty with it. The 2017 paper 2 question 8, very similar to that. So you've been given a recurrence relation, and you're asked to show that you could write down algebraically this expression for the second term in that sequence. So remember, recurrence relations are about using the previous term to get the next term. So in order for us to get to u2, we need to have first of all worked out an expression for u1. So u1 would be p times u0, right? That would be the term before, minus 8. Now you have been given the value for u0, so you know that u0 is equal to 4. That means p times 4, or 4p minus 8. So that's the first bit of this, is to come up with the expression for u1. Now clearly, to work out u2, we will be doing p times u1, the term before, and then subtracting 8. So here for us that would mean p times our u1 expression, we've just written down, we said it was 4p minus 8, and then we have the subtracting 8 part. So what we do next is multiply out the brackets, you get 4p squared, you get minus 8p and minus 8, and that was what you were asked to show that. So beside this, because it was a show that question, I would write as required. So we've been able to get to the expression that we needed to get to. That's our part, this is our part A. Now part B gives you determine the range of values for p for which, and it makes this statement here, that's in an equation, u2 is greater than or equal to u0. So really that's your starting point when you do the part B. Right, so with part B you're starting with this statement, it says u2 is greater than or equal to u0. Now you have just written down an expression for u2, so you're going to write down 4p squared minus 8p minus 8 is greater than or equal to, our u0 had a value of 4. You were told that in the question. So this is a quadratic equation. It's quadratic because we've got p squared term there. So how do we solve that? So you need to, first of all, right, must make the right side equal 0. Right, and then draw the graph, right, in order to solve. So making the right hand side 0 here means that my inequality would become 4p squared minus 8p subtract 4, that would be minus 12, and that would be greater than or equal to 0. Now what you then need to do is, in order, this is a quadratic inequality, in order to solve that you need to be saying to yourself, right, what I'm actually going to do is I'm going to draw the graph of, it's not x's here, it's the letter p, but it's the same sort of idea, y equals 4p squared minus 8p minus 12. Now in order to draw that graph, and we're not interested in huge amount of detail, but we are interested in you picking out or working out the roots. So in order to get the roots for your graph, you are going to put y equals 0. Right, roots are the points on the x-axis, remember. So you're then trying to solve 4p squared minus 8p minus 12 equals 0. There's a common factor running through there of 4, so I should divide through that whole inequality by 4, and I'm going to get p squared minus 2p minus 3 equals 0. I then need to factorise that, so I get p minus 3 and p plus 1 equals 0, and then that leads me to, right, my two roots, and my roots, of course, right, p minus 3 equals 0, so your root becomes p equals 3, you've got p plus 1 equals 0, so your root is p equals minus 1. So from that, right, you're then able to draw a little sketch, and it was a positive p squared. So this is the p-axis and the y-axis, and you're able to draw that shape of graph. And then from this, you make use of why you've drawn that graph. You remember this represents 4p squared minus 8p minus 12, and you're trying to work out where it's greater than or equal to 0. So you're interested in this bit of the graph, because up here, this is where y is greater than or equal to 0. So what does that mean in terms of our solution? And remember, it is the x's, or in this case the values for p, which go with that. So the shaded bits represent your solution for that inequality. So what you need to write down, right, your solution, and you've got this split solution, you've got p less than or equal to -1, and you've got p greater than or equal to 3, and that would be it. So that's what you were asked to do, right? You're asked to determine the range of values of p for which the second term is greater than or equal to the u0 term, and that's what we've been able to do here. So check through all of this work, look at your own solutions, look at where you might improve, see why you might not have got full marks. As I'm saying with this one here, just a test to make sure you've understood it is go back and do the 2017 paper 2. Question 8 will definitely help you with that.